Hey everybody, I hope you're all doing well. I just wanted to upload this video to talk a little bit about the create performance task directions and specifically what we need to turn in and what's going to be expected of you once we return from this school closure. So as a reminder, on Google Classroom we have this assignment that's posted. It says create performance task materials, and you can see here I posted these different attachments. The one that we're looking at right now is going to be the AP CSP student task directions. So if we pull up that PDF, if we go to the very top, it talks. This is produced by College Board, and it talks about the AP Computer Science Principles course in general. And if we go down to where the contents are, we can see here it says Performance Task Create Applications from Ideas. So we've already completed the Explore Performance task, and the first part is all just about the course in general. So we're going to look specifically at the Create Performance task. So if we go to the overview, it talks about creating a program and creating something that we can develop through software. It could be an application that you would use on like a tablet or a cell phone, or it could be something that would run on a PC or an Apple product, something like that. And so they're talking about the use of programs and how it could be useful to know how to create a program. So one important thing that they talk about here is your development process should include iteratively designing, implementing, and testing your program. So they're expecting you to maybe complete a rough draft of your program. And if you think of like Agile Scrum, we've talked about this, where you create something on the first day that is maybe just a a low bar, something that you can have just a functioning skeleton of your code. And then they expect you to, after that, create something that is a little bit more advanced. And when they talk about iterative designing, what they're saying is creating multiple versions of this same program that you save throughout. So instead of editing the same file over and over, they're really encouraging you to create multiple versions of this same file so that you can look back at your first pass at this program, and then your second pass, and then your third pass, and you can look at how you've developed and advanced your program. And that's going to be important because when we go back to answering questions on the performance task, they're going to ask you to look back and talk about maybe some struggles that you had with your program in the beginning and how you fixed those either complications with your code, or maybe it was just something that you wanted to do differently. So it's important to have those versions of your program. Also, it says that you're strongly encouraged to work with another student in your class. Now this is important. We are going to pair off once we come back. You're going to work with your partners that have been assigned, and you're not going to work with them on the same project. So you're not going to create the same app or the same software with your partner, but that partner is there to provide feedback, to help you if you get stuck on something, to be an extra set of eyes. So your partner is going to be really important to this project, and we'll talk a little bit more about what they're going to do to help you. All right. The important thing is you're not working on the same idea or the same app, but you are working collaboratively to help each other out, because throughout the process, I as the teacher am not allowed to give you feedback. All I can tell you is whether I think maybe your original idea is a good idea or something that I think you can complete within the timeline, but it's completely up to you to figure out what app you want to create, to figure out what program you want to write. So I can't really help you out with that. And so a peer could be somebody who can give you some feedback, let you know whether they think it's a good idea for your program, and also once you are actually implementing and writing your program code, to give you some feedback in terms of maybe how your app could work better, something like that. So that's how we're going to be working collaboratively. There are 3 things that you're going to turn in at the end of your performance task. So you're going to be given a minimum of 12 hours of class time, and what you're going to be turning in is, first of all, the program code. So you have to submit your entire program. They don't accept like Python files or PDFs of this, so what you actually have to do is somehow either take screenshots or be able to upload your entire program code in a format that they can open. And they give you guidelines in terms of what file types they can open. We're also going to provide a video of your program running, so being able to show your screen is going to be important. So if it's on a computer, we can use maybe a website to record your screen. If it's on a tablet, we might have to download an app in order to show your program running. You don't need to talk over the program. You don't need to have any type of subtitles or captioning. You just need to see the program run. That's it. And then also, we will have a template where we're going to be responding to questions about your program in the development process. So they talk a little bit more in detail about what we have to do while you're creating your program. Here's the portion that I want to focus on. It says, it is strongly recommended that a portion of the program involves some form of collaboration with another student in your class. For example, in the planning, designing, or testing debugging part of the development process. So this is where we're talking about the collaboration, right? It's not two people working on the same project, but you can work together in planning, so you can give another person feedback on their original idea. You can give them feedback on their program design, or after the program's completed, at some point, maybe after the first or second pass, you can help them by testing their program and talk about what you think would make it better. So that's the way we're going to work collaboratively on that, and I'll have kind of a schedule of events and a timeline to try to keep you, to pace you through these 12 hours so that you can know what to expect and what we're going to be doing each day in class. One thing that they're really going to focus on are algorithms and abstractions, and they talk a little bit more in detail a little bit later about what they're looking for. But algorithms are basically just something that you've created a series of steps to accomplish a certain task. So that tends to be a little bit easier for students to highlight and talk about. What tends to be a little bit more difficult is the abstractions portion. So the abstractions is either maybe a method that you created to make your program easier to read or run, or it could be something that's built into your programming language's API, so something like Tkinter or the PIL, the Python image library that we've been working with, could be an example of some abstractions that you're using, because these are functions that are built into the programming language that make your program easier to run. Makes it easier to use. From the user standpoint, if they're using a GUI rather than having to type their own code, if they just have to click a button in order for it to run, that's an abstraction that you want to highlight, because you're hiding some information from the user, right? They're not able to see the actual code running. Rather, it's something that's more familiar to them, like clicking a button or maybe even typing in text, something like that. So they talk a little bit about what you're required to do and the programming requirements. Basically, you can create any program that you want. It doesn't need to be very complex. In fact, some of the stuff that we've been doing in PL2W is probably more complex than you even need to make in this. But for the program, right, you have to be able to demonstrate mathematical and logical concepts. So being able to use like integers or floats, logical concepts like relational operators like greater than, less than, equal to. You can use Boolean operators like an AND or an OR, anything like that for logical concepts. You have to implement an algorithm that integrates two or more algorithms and integrates mathematical and or logical concepts. So we talked about what an algorithm is. So you maybe are creating multiple functions that are working together, or there's one part of your program that combines like finding the maximum value with sorting or something like that. You're just combining algorithms together to accomplish one larger task. So that's what we were going to be highlighting in one of our questions. And then you have to use abstractions to manage the complexity of your program. And here's where they give examples. So procedures, so like functions that you've created, or abstractions provided by the programming language. So something like a GUI or some functions that are already built into Java, or not Java, but the Python library. Here's some more details about the submission requirements. So you have to submit a video, and they talk about specifically what file types they accept, and it can't be larger than 30 megabytes. So the video is very short, right? Not to exceed 1 minute. So really you just show your program, show it running maybe from beginning to end in less than a minute. Written responses, we're going to look at this a little bit later in a different video, specifically what questions they're going to be asking us for 2A and 2D and what's required for each part of that question. So we're going to skip over this right now. And then the last part, when you turn in your program code, you're going to capture and paste your entire program code into this specific part in your digital portfolio, and then you're going to mark with an oval the key algorithm, and then mark with a rectangle the key abstraction. And then they also want you to include comments or acknowledgments for program code that has been written by someone else. So this is important. You can use program code that's been written by someone else, so either maybe something that you've taken from the PL2W curriculum or something that you looked up online, but it cannot be your key abstraction or your key algorithm. Okay, this has to be original code. But you can use something that was created by someone else. So maybe somebody's created a GUI that you think looks really cool. So you can use their GUI, but the key abstraction and the key algorithm that you highlight has to be your own original code. Okay, they talk about preparing and guidelines, things you can and cannot do. So you can read through this on your own. Again, I've posted this on Google Classroom, so you have access to this document, so you can read through this in a little bit more detail. But the last thing that I wanted to do is I wanted to just show you, right? Again, on Google Classroom, right? There's a link to this website here, AP Students. That's specifically for students that are in computer science principles, and in there we have this section, which is the sample responses and scoring guidelines. So these are from 2018, right? And these are some example create videos, right, that show the program running. So I wanted to showcase a couple of these just so you can see what type of programs they're expecting you to do. So this is the first one. This is created using a programming language called Alice, which obviously creates some 3D environments. And all he's doing is clicking on the blue ducks, and he's earning points for every blue duck that he clicks. And you can see there's a timer on the right-hand side, and when he clicks on all 5 blue ducks, right, it tells him he won. And that's the entire program. Okay, so obviously there's a lot of abstraction built into this. We don't see any program code. We don't see any type of coding at all. All he's doing is using mouse clicks to control the wolf and eating the ducks. There's a score and a timer, right, and that's about it. Okay, so very basic program, but we can see that this program actually received every point that you can get on the Computer Science Principles Create Performance task. All right, next one we're going to look at is a little bit different. This one is a text-based program, so there's no GUI, right? It's all just text-based, but you can see there is still some abstraction going on because he's not, or he or she is not typing any code. Instead, there's a bunch of questions going on, right? And then he's answering. So it just says input the definition and input the term, and it basically creates like a flashcard. And now these flashcards are saying input the term that is the definition of 1, and you can see this is like a French quiz. So he or she is typing all of the French numbers, right? Un, deux, trois, and so on. Right? So very basic text-based program. This one as well received full credit on the performance task. All right. We're going to look at D. Oops, not D. E. And you can see this one is a tablet. Same type of thing, right? Hint for text box 1, hint for text box 2. So they haven't even filled in the hints about what they're asking you to type. But you can see this is recording a tablet, and they're submitting, again, flashcards, and they're just looking at definition of, or not definition, but the meaning of these Spanish words. And they're typing it in and testing themselves, right? So hola means hi. Gracias means thank you. and so they're getting the right answer. Very basic program, but again, this one received almost full credit. There was one thing that they didn't do in their written template, one thing they didn't answer correctly, so they didn't receive credit for that. But the program was fine. It was just the response that didn't earn the credit. So a few ideas of different create performance tasks. I think the big thing for us to do during this school closure is to brainstorm. What do you think you want to do with your program? Choose something that you're passionate about. If you really like sports, then think about how you can create a program that revolves around sports, or maybe a specific sport that you like. If you like music, think about a program or an app that you want to create that revolves around music. You know, whatever you are passionate about, think about what type of program you would want to create. It could be similar to something that already exists. It doesn't have to be a brand new idea, but it doesn't have to be your own original program code. So just think of that. Okay? Alright, so until next video, I would say just brainstorm and try to think what type of program would you want to create. I'm going to post this video on Google Classroom. Underneath that video, there's a comments section. Right, so every assignment, if you click on it from your end, has a comment section. Comment on here what you think, what program you want to create. Okay, and I'll respond to those if I think it's a good idea. And then on Friday, we're going to look a little bit more specifically about the scoring guide and the template and how you're going to earn points for this assignment. All right, so I will see you guys on Friday. Have a good day.